I will immediately share my screen. First, if there are any questions or comments from your side that you want to start with before starting the lecture today. No? Okay, so if there is nothing you want, I will take this one. If there is nothing you want specifically me to talk about, then we will start with what we did last time. So remember, every time you will find here, okay, in the lectures, weekly info, what we discussed last time. Okay, so basically what we did in our last lecture was to finish the Wi-Fi part. So we talked about WPA2, WPA3, and we started to discuss some exercises from the previous exams. And I asked you to have a look so that we can continue today. So that we discuss the exercises in the last years, and then have, you know, because it's even for you like an example of something similar that you can have even this year for the exam. So we will continue with this now. I also want to add something because we finished the Wi-Fi part. You have another activity here, a Wi-Fi crossword. Something wrong here, 2 seconds, because I might be in a bad position here. Okay, so this Wi-Fi crossword here, because we finished the Wi-Fi, and there were many acronyms that we discussed, and maybe it's more difficult to remember them all. So basically, what you have here, it's a crossword. You have a game, okay? There are given a lot of acronyms. You need to know them. You need to understand what they are. There are some that you will see maybe we talked about more. There are some we talked about less. There are some that I expect you maybe to know from before. And you need to fill in this this crossword with the full name of these acronyms here. Okay. You can do that by next Wednesday. So again, it's an activity that will count like an activity for the lecture, let's say, during the lecture hours. But you can do it until next. Okay, not next Wednesday. Here I put it wrong, but next Tuesday. So after the 2 seconds to change it here, after the course. Okay. And again, who will do it will get one. What is this one? We'll get one extra point. Okay. For the activities, I mean. Because I'm in the wrong course like all the time. What's happening here? Just one moment, because this is not working proper. Okay. Okay, so you can do this until next Tuesday, end of the day. Okay. So I will remind about that even next week for the course, just for you to remember you can do this. And now I want to go back to the exam questions so that we discuss the questions. Okay, I will just download them. Or open in a new tab. We already talked last time about these ones. And now I want us to talk about the first exercise. Again, true or false. Respond with true or false. If the claim is false, make it true by enforcing a minimal change. Keep the same context, but do not simply negate. Okay, so for example, RC4 is used as a building block in CCNP. This is false. AES is used as a building block in CCNP. And if that would have been correct, of course, there was nothing required from your side. Okay, so nothing else to do. Let's try with the first one. How is this one? This can be a valid packet sequence number for WPA or TKIP. And maybe just to be easier, I will also get the slides. Because it might be easier even for you to have a look. Okay, so who can reply to this?
It's false. It's false.
Okay, why?
The packet sequence number, it's 48 bytes, and the hex values here, it's pretty longer.
Okay, really good. Okay, so if we think about WPA or TKIP, okay, we know, and I just search for the page. One second. Okay, so it's here. So we know that the packet sequence number is 48 bits. Okay, we were knowing that. So here it cannot be a packet sequence number because this number is not on 48 bits. Okay. So you can also expect something like this. So not necessarily, I mean, it is kind of theory, but it's a little bit applied. Okay. So it's in this sense, okay? Because you need to look about something and then realize, yeah, okay, what it is in fact. Good. In WPA to personal, in a WPA to personal network of 25 hosts, there exist 25 distinct CCNP encryption keys.
I think it's false. It's only one CCNP encryption key for all 25 hosts.
Okay, so there are not 25 distinct encryption keys. Now it is false, but that was kind of a tricky question because even, I mean, how was computed the key? No, in WPA to personal, the one for encryption. If you remember, I will try to bring here all the.
The PS key is derivated from the PMK. It's
Yes, it's derivative from the PMK.
okay. So the PMK is shared between the access point and the client.
Yes.
Is the same. Okay.
Yes.
So is the same. It's like is derivative from the secret or whatever. It's, I don't know what is named. The
Okay, the master. Yeah, it doesn't matter. Yeah.
Yeah. So it's the same for all 25 hosts.
But it was derived even based on something else, if you remember.
It's a secret, whatever, secret password. It's, I don't know, the
Yes.
initial password. Yeah.
And
The MAC.
And the MAC, very well. And
Some nonces.
And some nonces. So in the end, if we have one-to-one encryption key, there are different. No? Because if you remember, we were deriving them based on those. I will bring everything here, okay? So if you remember, we were having something like this. So, and now go back to the four-way handshake. And remember the four-way handshake, no? It was the master key, there were some nonces, and there were some MAC addresses. Okay? And the idea was that, okay, the MAC is different, the nonces are different. So in one-to-one, we have different keys. Okay, because these were the ones used for encryption, let's say. But why I'm saying it's tricky, because it's not really 25, because we can also consider the group keys that are also used for encryption. And we kind of all the time have at least one group key that is broadcasted by the access point. Okay, so I would put it false, not because there are not 25, there are 25 distinct ones, but the ones that are one-to-one, but we also have the group keys. Okay. So we have at least 25 plus 1 if we consider a single group key. Okay. I will not grant any points or anything for these questions, but I want most of you to, I don't know, to take part or to ask whatever is not clear, because this is something that is really similar to what you will have for the exam. So if there's something that is not clear, or just step in and ask or say your opinion, okay? Okay, see.
So, sorry. So in this case, when we are asked about encryption keys, encryption key means not the pairwise master key, but the encryption key that are derived from it and part of the pairwise transit key.
Yes, because the encryption key is what were in the end, where anything, no, that I was using for encryption. So if I think about the data and I don't even think about the APOL that is, let's say, higher. So there can be these encryption keys here, no? The one that I'm encrypting for the data. So it's a part of the PTK. A part of the PTK. Or can be these encryption keys here that are a part of the GTK. They are also used for encryption, no?
Could it not also be the YAPOL encryption key?
It can also, if you were considering even this one, I would have not thought it's a wrong answer, because even these are used for encryption. Yes. And I didn't specify data encryption. Okay. Yes, so was okay if you were saying that. Yeah. Okay. But anyway, even if I consider in a way, okay, but these two are in the same PTK and they can be 25 because I consider they're from the same and so on, the GTK is definitely different. And for sure I have it because I might have broadcast communication. So I need another one. Okay, at least one, but we were knowing there are more. Okay. The MAC header in WPA2 CCNP is input for the computation of the MIC.
It's true.
It is true. Okay. So the MAC header is in WPA2 or CCMP is input for the computation of the MIC. Okay, so if we go to WPA 2, let's see which was that one. This is 3, this is 2. No, these are the hash function from the previous course. Here, yeah. And we're looking, okay, what is an input, okay, for the computation of the MIC. So what is the MIC computed on? It is even in the header, okay? So basically everything, including the header, is authenticated, is computed this MIC, and then this message integrity code together with the data is further on encrypted, okay? So it's true, okay? So in this here we can only say, okay, it's true. Perfect. A direct purpose of the packet number in CCMP header is to protect against impersonation attacks.
The sequence number is helps us protect against reply attacks, which in particular we can think of as being impersonation attacks. So yes.
Why can we think about reply attacks as impersonation attacks?
Can we not? If we take someone else's packet and reply it, is it not as if we are acting as that person?
But if I'm not in general, I'm not meaning for this specific case, okay? But if I'm, for example, taking some packages, but I change something, for example, let's say that the header is not authenticated and I change the MAC addresses to be mine, or I change the ID to be mine, or things like that. I just use the data that I need. For example, just a response to a challenge response mechanism. Will that be an impersonation attack as well? What I'm trying to say is that I tend to agree with you. And if you would have, if you had written this one for the exam, I would have granted the points. But I'm not really sure that in all cases, the reply attacks are impersonation attacks. I agree that here, yes, it seems to be the case. But I don't think that in general reply, yes, please.
Yes, I wasn't trying to imply that they are always, that reply attacks are always impersonation attacks, but
okay. Okay.
Given that we have protection against reply attacks, we also have protection against impersonation attacks.
Okay. That also might not work. Because if the reply attack is one part of an impersonation attack, it doesn't say that I cannot have another impersonation attack that is not a reply attack and it's working. No? So I might have an impersonation attack in a different way than a reply attack. I don't know. I just, for example, somehow managed to clone the other device or the other and it's not a reply attack, but it's an impersonation attack. So again, if I have protection against the reply attacks, I don't necessarily have a protection against impersonation attacks. No, even if I consider the reply attack like a part of the impersonation attack. But I agree with you that it's good to go towards the reply attacks because yes, the CCNP header is used to protect against reply attacks. Again, if you would have put it like this, maybe I would say, okay, because you have a point, you thought something, but it's not, in general, this one should be false because it should protect against reply attacks, and not all the time I can say, okay, if I protect against reply attacks, I also protect against impersonation attacks. I might have different types of impersonation attacks. That doesn't necessarily imply reply attack. It's like, no, as I said, I just find out somehow the password, let's say, or the credentials, and then I don't care. I don't need to do reply attacks anymore, but I can do impersonation attacks. Does it make sense?
It does. I understand. I guess I just misread the question.
Yeah. Okay. But the thing that you went towards this one is really good because yes, it's about reply attacks. Okay. As AE, so the simultaneous authentication of equals in WPA3, it's a direct measure of protection against offline dictionary attacks. This is about WPA3.
I think it's true. This was the reason of
Yes.
WPA3.
Yeah, it is true. We were doing all these strange change of messages, no, that somebody said it's looking like a Diffie-Hellman. It does. It's not exactly, but it does looking like. So that from a password that might be even weak, we end up with the PMK, with the master key, so that it stands against offline dictionary attacks. And why is that? Because it's based even on some, let's say, new nonces, no? These values, R and M, that R, in fact, one chosen from for the station and one chosen by the AP. So it cannot be something offline before previous. It needs to be something online. So we cannot do anything offline because of that. Okay. As I was saying, because it's a key derivation function that it's depending on these values that are chosen in this exchange of messages. So this is the main important reason, let's say, for which we have the Dragonfly key exchange used in this SAA, simultaneous authentication of equals. So that was the purpose indeed. Okay, perfect. These ones we don't know yet, okay, because we did not study it. And I also asked you last time to have a look even on the other two exercises. So we had one in each of the exams that we have here as examples, and we can already talk about them or solve them. One is WPA2 security, and one is WPA3 security that is changed. And here it's in Romanian, sorry for that. I will translate it to English for the ones that are not understanding. So WPA2 security, let's start with this one. You're applying for a network security expert position at the well-known company UB Networks. That's the University of Bucharest Networks. It's an important company if you didn't hear about. In the interview, some of the questions refer to WPA2 CCNP security. So it is WPA2 using CCNP. Argue about each of them independently. So for example, question B is independent of question A. So don't consider one related to the other, okay? Okay, briefly explain the consequences of the pairwise master key PM key leakage. 1-2 paragraphs. So what can go wrong? What are the consequences if the PMK is leaked? Can you give me some ideas?
In one word or one paragraph? So it mainly means it's you are to say screw up if you leak the pairwise master key.
Okay.
So
Okay.
because everything is derived from there, you can get the the nonce and it's public. The MAC IP is public of the station or access point, so you can to say the function which it's used to say to derive the transient key. I think it's public as well. So if you have the PMK, you can derive the group master key or the pairwise transient key.
Yes. Okay. So in one word, as you said, yes, we have a big problem, and that is really correct, and that was the explanation, right? So once you have the PMK, because you already know everything and you can sniff them or you can whatever, and of course you know the keys, Kerckhoff principle, remember for scores, everything is known now in the system except the keys. You just find out the PTK. Once you found the PTK, everything goes away. So we go here, not here, we go, where was that? Here, no? So if the PMK is leaked, the PTK is leaked because we know this, we know we can check these ones, we know these ones, the F is known. So basically we have the PTK. Once you have the PTK, of course, you even have the GTK because that is sent encrypted, no, under the keys derived before. So we already know the keys. So it's basically all messed out. So we can read everything, we can impersonate anyone because we know the key, I mean the entity because we know the master key and so on. So it's very, very, very bad. Okay, but don't say, so if it's asking, okay, in a few 1-2 paragraph, don't write a lot, but exactly as you explain now, it's really good. So to explain a little bit so that I understand, okay, 1-2 paragraph, they know what they're talking about. Perfect. B, briefly explain the consequences of the EPOL MIC key leakage. 1-2 paragraphs again. So what happens if the MIC key used in EPOL exchange is leaked?
It's about the VPA2 or
Yes, so everything
yes.
is referring here to VPA2 CCMP. But now, compared to what we had before, we only consider that this key here is leaked. Okay, so we don't leak the PMK, we just leak this one.
I don't know if it's a tricky question or but it in the VPA2 the data encryption key and the MIC key are the same or?
Yes, but these are for the data.
Okay.
Okay, so not for the let's say the umbrella protocol. So remember where they were used in the four-way handshake, right? So in the first message, we had nothing. In the second message, we were starting to use a MIC. And this MIC was computed with what?
With the MIC key.
Which key? Which of these ones? Is this MIC key here or is this MIC key here?
The first one.
The first one. So it's ours, the one that is, okay, this is leaked. So what happened? So if that is leaked, what can the adversary do?
Manipulate the payload.
Okay.
And also do a man in the middle.
Yes, it might do man in the middle. How?
If he can take from message 2, he should be able to continue with 3, 4, and so on.
Yeah. And like a consequence, why? Of course it can, because it can basically compute the mixes, the message integrity code that the adversary wants. It has the key. So it can also change the nonces if he or she wants. And maybe the nonces will further take him to a better key, no? Like man in the middle attack. Perfect. Okay. So what you had to think about is, okay, where is this key used? Okay, it's used in the four-way handshake. Let's see what can happen there. Okay, very good. Perfect. Assume that the access point has a bug, such that any randomization it can produce is up to 32 bits of entropy. How does this affect WPA2 security? Do you know what is entropy? Think about it as random numbers. So all the numbers, when the access point has to generate some numbers, some random, uniformly random numbers, they are random only on 32 bits. So even if, let's say, the number should be 128, it's only 32 that are random. The others are bad, let's say, or somehow derives from this 32.
I think this would impact the nonces.
Okay, very good. So it can impact the nonces. So the access point has low entropy, bad randomization. Which nonces it can impact?
The access point nonce.
Of course, the access point nonces. Okay.
And
what
also
is
the sequence number? Was it from 1 or was it random?
The sequence number depends where we're sending it from. So it's depending on the, even if it's not random, I don't remember even me now. Where was this one? Here, no? We have a packet number. Yeah, maybe this one is just starting with 0. Here we have a counter for sure. But that's not necessarily that needs to be random, because it just needs to change all the time. Not here, not here. Yeah, here. So it's impacting the nonces and something else. What else is the access point generating as random?
The CBC MAC.
The CBC MAC is an algorithm that is computing the message integrity code. What from the CBC MAC? Or let's focus on the nonces first, okay? Where are the nonces appearing and what's the impact if the nonce of the AP is bad?
The PTK.
The PTK, let's think. If the nonce of the access point is bad, will be the PTK impacted?
I think more the GTK, because the PTK has a lot of other fields.
Which exactly other field from the PTK tells me if it will be or not impacted by the nonce of the access point? It's good, your observation.
So I think we have, because we have the nonce of the station there, it would not impact it as much.
Yes. More exactly, you can have a discussion here. If the nonce selected by the station, it's good. So if the station has good randomization and the nonce is good, I don't care about this one. Because overall, I will have a nonce. So I will still have a good PTK. If the access point, if the station also has a problem, and the nonce of the station is also poor, then yes, I have a problem. Because overall, I will not have enough randomization. But otherwise, this is the role, no, of using in both entities select their own nonces to somehow protect if the other, I mean, you don't trust the other to generate good nonces. You trust just yourself. So you don't care about the nonce of the other. So if the station has a good nonce here, I don't care about this one. Because the nonce will say, the station will say, okay, I trust this to be a good PTK. But here is a discussion. You could have said it like this, okay? If the nonce of the station is impacted or not. Somebody wanted to say something, sorry. No? Okay, while in the GTK, what happens? We don't have any other nonce. And more than that, is something else happening. So of course the nonce is impacting overall. But there's something else that differs in the GTK.
The GMK.
The GMK.
So
Where is it coming? Yeah, please. Sorry, can you repeat? I'm talking too much.
No, I wanted to say that it can be easy. It can be easier to found the GMK like that.
Why?
The access point nonce are easier to guess. So I don't know if it would be easier to brute force or something like that,
But I know the nonce of the AP because it's sending clear in the four-way handshake, so I can just sniff it. It doesn't matter, it's a real value, let's say. So with that, I don't agree, because in the end, the nonce, okay, it's bad, it might come back and so on, but I can still see it because I see it in the four-way handshake, right? But what is with the GMK? Where is the GMK coming from?
It's generated by access point. I think it's PRG. It's a pseudo-random generator, and if let's say the entropy is decreased to 32 bits, the GMK is also impacted directly.
Yes, because this is also generated by the access point. So this is what I was expecting to say, no? The GMK is poor because it has only 32 bits of entropy. The nonce is poor because it has only 32 bits of entropy. So overall, the GTK is poor. Okay, while here I might not have a problem because of the nonce of the station. Here I for sure have a problem in the broadcast communication.
So, quick question regarding the GMK. So, is not directly derived from the master key, or is the generated only using the PRG?
No, it's not derived from a master key. It's
Okay.
just why? Because if we think that we are in the enterprise solution, right? And now I did not check. I didn't check it, but this is how it seems logical. Because if we think about, so I suppose I'm not saying something bad, but if you think about the enterprise solution, in the enterprise solution we have different PMKs, right? But in the end we have the same GTK for all in the broadcast communication. So it cannot be derived from different keys. It's just chosen by the access point randomly. No? So yes, I have a problem here. I have a problem here. So I have a problem here. So overall, I have a problem for the confidentiality of communication when I'm talking about broadcast communication. Perfect. Good. And D, UB Networks is worried about the consequences that crack attack might have had against devices used within its network or by its employees in the terms of CVE 2017-13080. Choose a specific vendor, for example, Android, Apple, Alcatel, Intel, whatever, and briefly state the past and present impact of this CVE with respect to your choice. Refer to online sources for more information. How would you approach this one?
So the first one is to take a look to the CVE database to try to search this number, and
Perfect.
then to try to see the fixes, if any, to say. I'm supposing that all the vendors fixed that, just to say, to describe what they discovered and how they fix it.
Yeah, so this, and you might expect to have this kind of exercises, is just for you to know how to check things online, because most of the time you will not need, I mean, things are changing. You finish the master now and then you need something in 5 years or 10 years or whatever. So expect to have this kind of questions as well. So you either go here and then you check and you see the description and you see it's okay, it's related to Wi-Fi, it's related to the group temporal keys. And then you have a lot of confirmations here. Maybe we have some Oracle, some Apple support, some Lenovo, whatever. You choose one, you try to understand what's there. You check if it was fixed or not. You draw some conclusion, you write your answer in a few phrases. Okay, well, how much was 1-2 paragraphs again, I think. Where was this? Here. Yeah, so briefly state, okay, the impact. So this again is an open question. Okay, I suppose everybody knows what this CVE is. Did you hear about this before? What is the first time you hear about this?
I think it's a first for me.
Okay, can somebody explain what is this used for or what is helping us with?
I'm trying to say to say some more. So it's just to say it's like a database of the incidents discovered on the security incidents, and it's to say like the knowledge database tool used by both the security engineer and to say on the developers to fix the stuff. So usually the reporting a security is not like going here and filling a ticket, but is like disclosing first to the vendor and try to solve it, and after that reporting to the database to make it available across community.
Mm-hmm. And there are some similar things that maybe are not so well known. So with TCP, it's CWE, weakness enumeration, and then it's this common attack pattern enumeration and classification as well. So you might want to try a look in all of them. I put the link here. So one is, okay, there are these problems as you were saying, no? A list of common identifiers for publicly known cybersecurity vulnerabilities. Then somehow related, let's say, it's another one that is really interesting. And I'm using quite often. Now I took this link also from a lab from the undergraduates now. It's for, let's say, general weaknesses that can impact different things, okay? So basically, if here I have something that is a really specific vendor a device or something, here I have something that in general you should not do. Some good practices, let's say, or some bad practices, something you should avoid or something you should do. And then in the last one, you have all these type of attacks, let's say like a taxonomy of attacks, a classification of all the types of attacks, and you have this connection between them. So for example, I have an attack that it usually can be exploited because I do something bad, and this is what I do bad, and this is how it has been done for a specific vendor or a specific product. Okay, so this is something that it's nice for you to have a look at from time to time. I don't know, just to give an example, you can just go there and you can search, and you will see a lot of nice stuff, no? So example, if I want something about the PRNG, yeah, because we were talking about this one, the small seed space, okay? So if I enter in a pseudo-random generator just a small seed as the input, then it's of course more susceptible to brute force attacks, okay? So for example, I have here, I don't know how well you see because it's maybe too small. So if I only have a seed, sorry, that uses 2 bytes of randomness, I have a problem. I should use more, okay? And this is something that's general. So in general, I should not use 2 less randomness as we had before. And here is an example, okay? This specific product or this specific device or this specific library or this did that, okay? So this did that, it was a 48-bit and it was easily broken, and that was not fine, okay? So basically here in the CWE, you have some general things you should not do. And then in CVE, you have, okay, this has been done in practice here, and this is how it worked out bad, okay? And of course, the last one, as I was saying, you can check about, I don't know, again, seed, let's see. Brute force, okay? So brute force is a type of attack that I can do because, yeah, it's this type of attack and I can execute it like this and things. And this is not something related to network security, okay? So this is in general security. You find here everything. You find software security, you find. So it's a good thing to have a look at, okay? I basically added the link here. So you will, you can just have a look in all of this without any problem. Okay, perfect. And that is all, because the other we cannot discuss is mobile, so we didn't discuss mobile yet. And if we go to the second one, I didn't ask, but I suppose you don't want a break, like always. We continue. If somebody wants a break, let me know. If not, no break, so it seems fine. We continue with what we finished before. Okay. The other exam, it will WPA3 modified or changed. This is more mathematical, and you can also expect something like this. So again, I'm expecting you to have some basic notions, both crypto and networking. Okay, we don't start from scratch. So one of your colleagues said that he changed, or she changed, WPA3 to be even better. Because we know WPA3, no, it's susceptible to some attacks. So how it is changed is illustrated here in the figure here. We have a client, we have an access point. They both have a password PWD, which is encoded by a function f in a point P on the elliptic curve. Okay, so we start with the password PWD, which is known by both the client and the access point. It's somehow encoded with the public f function in a point on an elliptic curve. And the elliptic curve EC and the prime big number Q that are used for the protocol are also public. So basically, we know all the parameters that we're working on. What we don't know, of course, we don't know the password. Okay, and here is the change. And if we look, okay, but what is changed with our protocol? Let us see. So basically, this I will make it smaller now. How can I do? What is really changed here? I will try to do it like this. Okay, if you have a way to watch it both, it's also good if you can do it locally. So basically, what's the difference? I don't know how to make this one so that, because otherwise it's too small and you will not be able to see anymore. Easier to check it because I gave here the source before the modification. So what you can do, you can get this paper, no? And it's even here, it's the ePrint archive. You can also just search for it. So what we do, we go, let's say, in Google Scholar. You know about Google Scholar, I suppose. I check if I have access to the paper. If not, it's not a problem because it's free in the ePrint website. Okay, so you could have get it from there. And I check where is the difference. Okay, and if I check this, I don't need anymore. And if I check where the difference, it seems that I don't have something here. See, it's basically the same image. Yeah. And here I have some verifications. Okay, so I verify the SB and I verify the EB or SA and EA. Okay, so here is just this one that is deleted. Okay, so the first step was, okay, let's see what's happening. Let's see in our slides. In our slides, I put the verification I did. Okay, so it was this, the verification of this one or the verification of this one. Okay, so it's basically the same thing, but in a different, let's say, different writing. Okay, so I found out that which is the difference, just for me to know. First question, show that the access point and the client compute the same key K. Okay, so which is our key? In the end, it's not this K, but it's this one here, but it's a hash of that one. So basically, if the small k is the same, the big K should be the same as well. So what we need to do some math computation to check that this key here is the same as this one here. Okay, and basically it's array times SB times P plus array times EB, and you can replace what EB is. And you will see, okay, it's MB times P, and then, okay, but what is SB? And you replace here. And in the end, by doing the math, you should end up with the same key. I don't know if it's something that you want us to write down now. I think everybody can go over that and do the math, okay? Do you want me to write it down? Or do you think you can manage? No feedback from you, so what I'm supposed to believe?
We can do it. We have an exam to say on advanced network in 2 weeks from now, and we have to do it for that exam as well. So it's should be simple.
So you did this one?
Not necessarily, but it's close to that. And as I said, we will have the exam on 24, and we have to say to do the math before the exam, and we'll have some exercises that cover.
Perfect.
This time.
This is advanced networking.
Advanced security.
Advanced cryptography.
Advanced
cryptography. Yeah, sorry.
With our colleague Mihai Prunescu.
Exactly. Yeah.
Okay. Perfect. Yes. Okay. So he's helping me. So you're doing that for advanced crypto. So you should know. It's just basic math. You also did there the elliptic curves. You talked about elliptic curves a little bit.
I skipped the classes so that, but it's in documentation. Yeah.
Perfect. So that's why I expect you to know. We will have the exam later in January. One parenthesis here. I would kindly ask you to put the exam as earlier as possible in the exam session. So if possible, just to be the first exam that you have in the exam session. So just please consider that when you will set up the exam date. Okay, so that is the first thing. The second, the client and the access point are using a password that is very wide used. Can an adversary that doesn't know anything about the password except the fact that it's very wide used can determine this key K? You should consider that the discrete logarithm problem is easy for this elliptic curve and this P derived from the password. And what that means, you should now know from advanced crypto, but what that means, it means that if there are given Y and P, it's easy to compute X so that X times P gives Y. So that means the discrete logarithm problem is difficult, okay? Can an adversary determine this key K? Again, this is math. So if you say that you need to learn until 24 for this exam, I propose to do like this. We don't solve even this one. And maybe some of you is writing it down and then it's we discuss it. Because it's again, let's say, kind of math related, unless someone is just seeing it now. So we consider the discrete logarithm problem to be easy. And then you know that the password is derived from a weak key. And the question is, can you determine the key K? Maybe it's not so easy to see before doing the math. So just to give some hints, what you need to do here is look at the final value of the key K after you did the math for the first point, and then see, okay, the P is coming from a weak password. So what does that mean? That means that even the P can be weak to brute force. Okay. And then I know that the discrete logarithm problem is easy. So it's something that I know because I can sniff on the communication medium. And knowing that this discrete logarithm problem is weak, it can give me something. What is this something that I can get? Knowing that even the password is weak. Where do you see directly like this the discrete logarithm problem?
In the formulas for EA and EB.
Perfect. Yeah, so here. And what I know, because I can sniff.
EA and EB.
Perfect, because I see them on the medium. No, I see when they're sent here. Perfect. So what can I find out? So again, I look
MA and MB.
Perfect. So the password comes from a weak password, so I can do a brute force here. So I can find MA and MB up to a brute force. So I can have more values for them, but not so many. Okay. And then with them, because in fact the key is only depending on MA and B and the password, I can find all the possibilities for the key K. And then knowing the hash, of course, I can find this one because the hash function is public. And then I can check to see if my guess was correct for the password, okay? Because I can check if the CA is here or the CB is correct for this, all the possible keys that I find. Because TR is public again, SA, EA, SB, SB, this I have on the medium, right? So I can just sniff. So again, the password is weak, so I can try a brute force. EA, I know, I can find all the possible MAs for all the possible weak passwords, okay? With this MA here and the same MB here, I can find the key. You will see it's only depending on this if you do the math for the first one. So I can get some possibilities for the keys. How do I find out which is the correct one, which is the good one? I just compute the hash. I compute the TR, that are all public values. And then I compute for each K the age MAC. And I check, is the age MAC the one that I see here? If yes, I found the key. If no, I go to the next password and I try again, and so on. Okay? Really good. Perfect. See, the software of the client and the software of the access point have been infected by a malicious program that affects the generator of the pseudo-random numbers. This leads to the fact that MA and MB are, with a high probability, equal both with a constant value val. So that means both MA and MB take a specific value val. What can you say about the security of the system? Discussion. And as a note, this is independent from the previous point. So we don't consider the password any more weak. It can be a strong password. And you need to think for the both cases, if it's strong password or if it's a weak password. And again, the EC can be an elliptic curve for which the discrete logarithm problem it's good. Okay. But now we have this problem, MA and MB. They do have a problem. And the problem is that they are very often equal to the same value val. What is happening here?
Do we know that constant value val?
We can know the value val. Yes. Yes.
If MA and MB would be equal, then EA and EB would be equal as well.
That is a very good observation, because this is how I realize if this is the case where the generator works bad. Because I said, okay, with a high probability, but I don't know if it's happening or not when I see. But if I see EA and EB equals, I know this is the case. So MA and MB are equal with this val number. Perfect.
And this will lead to say to reusing the key and capturing to say multiple ciphertext, which are reusing a key can I don't know, lead to trying to say to guess the plain text by using the statistic against, say, I don't know, a frequency of the letters from the plain text and so.
Yeah, but that's a very good observation again. So what will happen if they are the same? I will have the same key again and again and again. So that's a very good observation. Whenever I see EA and EB equal, then it means that I have the same key here. I reuse the same key. And of course, reusing the same key, depending on how much I use it, how many times I'm using it for encryption, what I'm encrypting and so on, I have a problem. I should not reuse it so often. Okay, so that's why it's a discussion. And here you can come up with whatever, yeah? So, okay, if I consider the P to be strong, not like in the previous point, I have the reusage of the key, which can take me to problems. If, of course, the password is not so strong that it's really easy to find it again, like in the previous one and so on. So that's where the most important things to notice here. First, that I realize this happens because MA and MB are the same means EA and EB are the same. And then when EA and EB are the same, because MA and MB are the same, and because at the first point I computed K depending on those, I realized I can have the same key over and over again that is used. Okay, so that is very good. And D, for the moment, this proposal is just in testing phase, but your colleagues want to implement it for the internal communication within the company next week. Can you give an advice, but with some argumentation, why you're giving this advice to your colleague?
So no way to go with this implementation to production without having a thorough validation before that. So it's will expose to say may expose the whole company at risk, even if it's to say only used internally.
Yes.
As to say the more than half of the total attacks are insider attacks. To say it's
very good. Good. So that might be okay. Don't take it directly. I mean, okay, next week you put it in production, but test it, try it more, see what's happening, see that you have some vulnerabilities that we were talking about. Yeah. So it's not a black or white answer. It's something that you need to explain why you would give that advice, and the advice Georgi gave was very good. Yeah. and he also explained why. So these are the types of exercises you might expect to have at the exam. Okay. If you have questions about what we discussed until now. The others we cannot discuss at the moment because there are things we did not study yet. Okay, but we will. Now we have some more time left, and I want to emphasize something. Remember about the projects, the course project, the lab project. For the lab project, there are some students that registered. For the course project, we're really, really bad. So I think there are only 3 people. Yes, 3 people that got a topic and registered for the course project. And I want to know why. It's because you don't know the topic. Because what I proposed myself to do now is to talk a little bit about 5G. Even if we did not start it, we will start talking about 2G, 4G, 3G. Maybe we skip because it's not something exceptional. But I want you to start choosing projects and dates for the course project, because otherwise there will not be time for you to present, even the people that are coming often and so on. So my idea was that you're not choosing this, you're not sending me an email and say, I want to present this and in that day, because maybe 5G is something that you don't know where to start with or what to talk about. Am I right? Yes, okay. So I want to give you some hints where you can find some topics about 5G, what 5G is, what it means, if you can find something about it that you're interested. And the first thing to go or to start with is this additional materials here, where I put some links, okay? And the best ones to go is the ones of the organizations or the institutions. And you can find here very nice resources about 5G. For example, I will start with the ENISA. The ENISA, as I was saying before, is the European agency in cybersecurity. So whenever you need something not related to network security, but in general, it's fine to search on the ENISA website. So I can try to find here something about 5G security, and let's see what it gives me. It gives me a lot of items, let's say. I want to sort on relevance. I have some forums. I have some agendas. Maybe it's something that I don't really like. I have some training on 5G. That might help, yeah, or might not help. But I have really a lot of documents. So maybe I go to publications. Let's see if it's better to find just publications. So I find 5G security, and I find 5 publications. So 5G guide to security measures, security in 5G specifications, threat landscape for 5G networks, signaling security in telecom. Diameter, if you remember, I was saying it can be seen as the newer version of the radius that we kind of studied for WPA, right? And some good practice for software-defined networks. What would software-defined networks be? I don't know if you did that for something else, probably not. So you can go to any of these, just like an idea. You can download the paper. Okay, allow. And then you can check what's inside. 2 seconds to finish the download. Okay. And here is, I have the download. Okay, security in 5G specification. And this seems something that it's easier to read, let's say. Okay, controls in 3GPP security February 2021. It's even new, I like it. Okay, it's not something that is old. And then you can check what they are talking about here. Overview of the standardization efforts. Okay, security specifications for 5G, because 3GPP is the organization that in fact is doing the specification. We will talk about this in the mobile networks as well. Some security aspects, conclusions, and so on. And you will find here maybe some important things. Okay, it gives you ideas. It gives you things about, okay, 5G security, where I can look if I want to search something about 5G security, anywhere here. First, the 3GPP that is doing it, but even IEEE, UTT, CATF, and so on. Okay, it's explaining me, okay? It's giving me something that is really important, and we will look into that. The working group that is focusing on security. So basically in the 3GPP, there are people that are, let's say, gathered, organized in working groups for different aspects. So if I think about 5G, what is 5G? Even if I don't know anything about 5G, it should be the 5th generation of mobile networks, okay? So it's something that is more than the 5G that probably most of us are using now. What I'm caring about is security. So if I want something really specific, I can go to the 3GPP and search for the for this group here, and we will do that as well. Okay, so then it's giving me some security architecture. Okay, some security specifications. So here I have all the list of important specifications related to security. If I want to go to the standards, okay. Use cases, if I want to go to the standards. Authentication and key management, how it's working with the credentials, if I want to do that. And so on, okay? Then I have, I don't know, the security algorithms group that are talking about what security algorithms I can use in 5G. I will not go over everything, okay? I can look about the security from different perspectives. And here there are many things that you can just choose one of them and talk about that one. Okay, so I can look at the security in the access network. I can look at the security in the core network. What is the access network and the core network? Maybe you know, it's something that we're going to see for all the mobile networks. Basically, the access network is a network that is very close to us as users. So, for example, it's the towers, the antennas that you can see everywhere in the city, no? And our phone is connecting to. That is part of the access network. While the core network is the switching center, all the databases, everything that the network operator is keeping to provide me services. Maybe the big, how they're called, the rings of fiber optics, if there are, and so on. No, so all the big infrastructure that I'm not connecting directly to. So whatever I'm connecting directly to, it's a part of the access network. And then I can have something about the security of the applications, service applications, okay? And I can have a look at different aspects, the area interface. Here there are very nice things that are related to 5G. The MEC, the SDN, the NFV, these are notions that are coming, that are appearing, let's say, very close related to 5G, and which the security of which is raising a lot of problems. Okay, and then the same I can have in the core network and so on. Then I can have a look, okay, but what is really happening? So maybe if I want to go about something in 5G that is related to something I kind of knew before or is more familiar to me. And maybe you already know the TLS and you want to say, okay, this is how TLS is used in 5G. Or maybe you know more about the authentication to zero. and then you want to talk about this one in 5G. So you can also do things like that for the project, okay? I will not go over all this, okay, because we're losing time with this, but it's just for you to get an idea. And this you can do with all, sorry, this we don't need anymore, with all these publications here. So for example, this is also really nice. It's a little bit older, but it's also nice. There are the threads for the 5G networks, and they have a very nice map of threads. If I can open it here. And I also want to show you this because basically we will not discuss 5G more than your projects, okay? So it's good for you to know all this stuff. So this is a very nice document as well, where you can find the risks. And if I'm not wrong, is this one? Yes. Okay, where you can find a lot of risks and the methodology adopted to think about these risks. Okay, so we can have risks, vulnerabilities, threats, countermeasures, owners, attack vectors, and so on. And this again are something that is general. Okay, it doesn't apply only for 5G or mobile networks and so on. So it also might be interesting for you. And then you take this one and you apply it for your 5G. And you see, okay, where I have some problems. For who? For the stakeholders, for the users, for the, I don't know, in the architecture, and these are really nice. There was something at the end, I think. I will just go directly there. You can have a look and get ideas from here, yeah? Where you have all these very nice tables, where you have this generic threats in 5G. And that is also a thing that you can think about as a project about 5G. You focus on something specific, okay? And again, the threats or the impact are not, okay, here the impact and the affected assets are particularized for 5G. But in general, you can think about these kind of things like threats and countermeasures and mitigations and vulnerabilities and in general. So it's something that it can help you for other things as well if you don't want to go to mobile security, okay? And again, you can find something here that you like and focus on that one. If not, again, you can get some acronyms from here, again, the MEC and the LDN and the MANON, that are things that really related to 5G. Of course, you can think about softwarization, right? Because I don't know if they even have this somewhere here, specific physical access, damages, malfunction, disasters, legal. Yeah, okay. Because in 5G, we put really a lot of focus on softwarization. So you can think about, okay, how it's happening, the security of APIs in 5G. What is about that one? Okay, where is this happening? Think that you have just 5 minutes for the presentation. So it doesn't need to be something really, you can just give an idea, but to be clear. Think about nobody, and you saw that's why people did not choose topics. Nobody knows anything about 5G. So make it 5 minutes, but in 5 minutes, people to learn something. Okay? Not to be really simple, like, I don't know, we are master level, but not to be really, nobody understands the thing. Okay? Because then it's not used. And remember to give me something after the presentation, slides, some text, some website, something that people can learn, because there's going to be material for the exam as well. So this was for ENISA. I want to show you just another thing. I want to show you even the 3GPP. Okay, so again, you have it here, the 3GPP. And the 3GPP is the one that is basically writing the specifications. I go to specification groups, and now I know where to find this group. So I go to specification groups, I go to SA, and I go to SA3, because it was the working group 3. We already saw that in the ENISA document. Okay, so I go to the security. I have here the security group. I have some releases. You can also speak about what releases means and so on. And I want to go to documents again. Oh, but they look so bad. I don't want to go to documents. I want to go to specifications. And here I find all the specifications. Some of them you saw there were also in the ENISA because they were the most important ones related to security. And if I want something about 5G, I already find here very many. Okay, so security architecture if I want to check. I don't know, the user plane if I want to check. This might be more difficult to read because it's something that it's how can I say, it's you will see it's very specific and they are not so easy. It's not like a white paper. Okay, but they are but if you want something really specific or you need something that is exact, you should always go to the specification. You can also look for I don't know, white papers that gives you ideas. Okay, about 5G security. I also added here, if I go back to lecture materials, the courses from last years. And if you go from the course from the last year, 1 second, because my download is working not so great. Okay, you also can find in the really end some information about 5G. Okay, because last year the it was not 5G the topic for the project. So very briefly, I gave some ideas about 5G and what 5G is. Here you notice is the one from the ENISA. Okay, here are the standards. Here is the architecture of 5G. Here is how the user equipment, that means the mobile phone, let's say together with the SIM card, can get privacy within the 5G networks. Okay, here is how we use public key encryption for keeping private the identifier of each subscriber. So we will start talking about from next time, basically, what is the thing that identifies our phone within a mobile network? Do you know? We need something to get us in the network. What are we using from the phone?
A SIM card.
A SIM card, perfect. We have a SIM card, and the SIM card is storing a key. We will see a cryptographic key, and it's storing an ID, an identifier of the subscriber. And this identifier can be encrypted in 5G only using a public key crypto, so that I don't know to get anonymity, let's say, okay? Not people to know who I am. Because if I'm sending all the time my ID like this, people can sniff it, for example. Another idea, because I just got it now, about the SIM cards. Do you know other type of SIM cards rather than the cards that you just go in the shop and take them? Or should I ask in another way, does somebody has a SD card? Yeah, but I'm referring still for the SIM cards. But let's say smarter or newer or something different, not to have a card, a physical card.
eSIM?
eSIM, okay? eSIM is also something nice. Let's say not fully related to 5G, but it's something nice. What is an eSIM?
A virtual SIM?
A virtual SIM. And where it was first maybe introduced, we know like this from the media at least. Where did you first hear about the eSIM?
I'm not sure if it was the first time, but I heard in small devices like watches and so on where you can't insert a physical SIM.
Yep, yeah. The Apple Watch is, even for me, when they came, at least in the Romanian media, were like the ones. And what it means is basically I don't have a physical SIM card that I put there. It's an electronic SIM, let's say. It's like a software SIM, and it can give me some facilities because I can update better. I can change the key. I can use more keys maybe, but of course then I have a drawback as well. Not being physical and temper resistant and everything. If I want to do, for example, updates through the air, over the air, that are really on fashion for the web, for the phones and so on, I might have some vulnerabilities there as well. But it's also a nice thing to look into. Again, not really connected to 5G, but might be accepted. And then how it's happening, the authentication in 5G. So the AKA, authentication and key agreement. And we will talk about this in 2G, 3G, 4G. And then the key hierarchy. So what we did for, let's say for the Wi-Fi, we had the master key, and from the master key we were deriving the PTK, and from the PTK we were splitting into 4 and so on. The same even here. In the SIM card we have a key that is the master key. It's a key here. And then from this key we have a lot of other keys used for different purposes. Because again, we need to take care about the principle of the key separation that we talked in the first course, So one key for encryption, one key for integrity, one pair of these two keys if I want to think about the data of the users. But what if I want to think about other type of communication that I need, like control, management, and other things that are happening there, not the data necessarily, Then I need other keys and so on. Then you can think about mobility, how mobility works in 5G. You can also think about constrained devices, because we were talking about smart watches and things like that. Maybe I have some sensors in 5G that are sending how much heat I use this month so that they make me pay. And that have some very strict restricted capabilities. I cannot use whatever I want there. What's happening in that case? Maybe it's also something nice to look into. Then the cryptographical aspects in 5G, what I'm using. I'm using some specific algorithms, some specific primitives. Do I have some weaknesses here? Because in some specific cases, I can maybe not use encryption. Or maybe I can do downgrade attack to one of the previous generations. So again, I have a problem. And things like that. And then there are all these new concepts that I've told you that are very nice. The software-defined network. So basically, we tend to do everything in software and less in hardware. And that can be good or can be bad. So not having specialized hardware for different things. And NFV, network function virtualization, when basically I try to implement the functions of the network, like routing, for example. No, we have routing in the network, but not to do it in a specific router that this is his job to create a routing table and route traffic from here to there. But have something that is again software that is high level and that it can think overall in the network. Again, very basic thought. I think about the load balancing that we were talking for the lab, the ones that were the lab and attended the presentation. Maybe I want to have an overview of the network and then balance traffic as I want so that I gain something. Then is this Mac that I was telling, that is mobile edge computing, that is somehow similar to cloud computing, but very close to the user. So think that you get the cloud and you put it very close to your phone, to your devices, to your end user. And you gain some things and of course even lose some things. But again, it's a trade-off, and it seems that you gain much more than you lose. And then it's about network slicing. That is a very nice concept as well. And you can talk about isolation if you like, for example, isolation in software or no, because most of it's as I said, mostly software. I don't want to keep you more because we're already finished, but I hope I gave you a little bit of hints. So try this, the one from last year, maybe it gives you some ideas. Try here what I put in additional materials. Search NESA, search 3GPP. You can, of course, also search in E2T and Etsy. You might find some interesting stuff there as well. Think about something not too big and try to explain that one in 5 minutes as you have. Okay, if you have some questions.
One question regarding the low entropy of the access point.
Yes.
You mentioned that the group master key will be impacted.
Yes.
So I thought that the group master key is exchanged in an encrypted payload. It's not visible. So even to say that it's the group master key, it's weak. It's encapsulated, say, by the PTK, and to say an intruder won't be able to say to sniff it or to use it, even to say the PRG, it's or the entropy of the PRG is lower.
But it's not the only way where you expose the GTK. When you're also exposing the GTK.
It's exposed in the step 3 of the EAPOL in the four-way handshake.
I don't have it anymore. Yeah, but there is encrypted, as you were saying. I have it.
Yeah.
But here it's encrypted.
Exactly.
So as you say, maybe it doesn't help because anyway it's encrypted.
Yeah.
So, but I also expose it in another way. Who can help us here? When I always expose a key, in a way, expose it.
When you whenever try to make something or someone log or register?
I'm not using this one for logging.
Could you repeat, please?
I'm not using this one for logging or registering.
Yeah, I mean for trying to access any handshake.
No, but any
Maybe
key in general, every key that I'm using, I'm exposing when I'm using it. So the group key at some point will be used to encrypt group communication. And I can try by brute forcing to decrypt that messages. So I don't necessarily need to think it's weak and find it somehow from the handshake. I just know it's weak, and whenever it's used, I can try, let's say, a brute force on the encrypted messages.
So you said that once to say the station will agree to say to communicate broadcasting or multicasting with the access point, then they will use the GTK for data encryption?
Yes. The GTK is used for this one. Okay. So whenever the access point has something to send to everybody in the network, it will use the GTK.
So, okay. So will not be like using the PTK for the data encryption and inside to say the payload using it's like
no.
Okay, I see.
No, directly the GTK, because what I want to do, I want to be efficient. If I use this one, I need, if I have 100 devices in the network, to encrypt 100 times. I don't like it.
Yeah, thank you very much. I think I got the point. Yeah.
Okay. Other questions if there are? If not, sorry for keeping you 5 minutes after. Thanks for attending. Have a nice evening and see you for the lab or next week for the lecture. Have a nice evening. Goodbye.
One question.
Yeah, okay. I remain with you if people want to go, please. Yes.
As I want to communicate to you the main idea and what I want to ask is about this class.
Yes.
I had some problems last year with you and couldn't pass.
Okay.
As you know, we spoke about this and
yes. So you want to present something before or what? I don't know. Tell me what you need.
A subject for homework.
But there are not the homework. There are the first the labs. I don't remember what you didn't do last year. So there are the labs, and there are the projects. Okay. Are you here in the course of this semester? Are you enrolled?
Yes.
Yes, perfect. So see here the course projects and the lab projects. Okay. Then just send me an email and just say